It's me, Rochelle, again. So welcome back from your break. I'm happy to present our next speaker, Sam Vanhoutte. Sam is the CTO and Product Manager at Codit, based in Belgium. Sam is a Microsoft Integration MVP and also a BizTalk Virtual Technology Specialist. He has extensive experience in building integrated enterprise, ESB, and SOA solutions. Sam is also a part of Microsoft's Connected Systems and Azure Advisory Boards and a Windows Azure Insider as well. Sam co-founded the BizTalk user group in Belgium and is an active crew member of the Windows Azure user group. Today, Sam is going to talk about integration of things and why integration is key in IoT solutions. He tells me that a lot of you in the room already have all the required skills, and so you should be able to build good IoT solutions. So I hope you all find this session very informative. So over to Sam now. Thank you.
Hello, everybody. So as you know, I'm Sam Vanhoutte. I'm a CTO at Codit. And today I'll talk about, integration, but integration of things. So we've been doing integration since the early 2000s. I've been working with all the BizTalk versions ever. Although the last version is probably a little bit less than the first versions. Because I switched more and more to the Azure solutions, especially in the IoT space. And with IoT, what we can see is that there's a lot of skills, a lot of patterns that come back, and patterns that we have been using in the last 20 years almost with integration. So most of these things in this session will be on that. The good thing is that there's a session after me by Mikael, and he will be diving more into the technical details. So I left all my technical stuff out of my presentation, and this will be more of a real introductory session that will lead to the technical implementation session of Mikael. A few words on the company that we are. There's also a few of my colleagues here. You might recognize them. We are 134 at this moment, and we're based in 7 countries. These countries are in Europe. And the thing is that we focus on integration. We've been doing that since the year 2000, but we added a lot of extra domains in the past years. These domains are API management. These domains are Internet of Things, and of course, Azure solutions in general. So you see that IoT has been added, and it feels like a natural evolution for what we offer. And that's what we have seen in the past sessions also, is that integration is no longer just about dropping a file on an FTP and moving it somewhere. It's also no longer just gathering some tweets and put them on Dropbox. I think we have, if you see at this conference compared to last year, we've seen a lot of more enterprise-oriented integrations, including cloud, including on-premise, focusing on a lot of hybrid stuff. So that's really what we also see at the solutions that we built. The good thing that we also have is that we have been working with Azure engineering teams, the Azure IoT engineering teams, because we're one of the 5 Azure IoT elite partners worldwide. So the good thing there is that we have that close collaboration with the Microsoft teams of IoT Hub, of the IoT Edge, and things like that. Now, enough about what we do. What you can expect in this session is really mostly about learnings, about concepts. I'll share some experiences, some findings that we do in the IoT projects that we have been doing. What I don't do is demos. Sorry for that. Because I only have a big half hour. And I'll try to do it, really conceptual. And this is really the diagram that we always use whenever we approach customers, when we talk to people on what do you do with IoT. And it's always about, this end-to-end value chain of IoT. And there's not a lot of partners, including us, that do everything. There's not a lot of partners that do the devices, that make these microcontrollers, that do the big data intelligence, that do all that gathering, the deployments. So most of the things that we have seen is that really IoT solutions typically are, an ecosystem of different partners that have to work together. I think that's really important to find out. The points I will make, and I will conclude at the end of this session, is really that in this entire IoT value chain, there's a lot of points that really link with integration. A lot of points that have a connection with what we have been doing always. If it's about API, if it's about messaging, if it's about business rules, all these things typically come back. just in the different types of technologies. So connectivity is really the key. Everyone that sees these nice reference cases of Microsoft, of IoT, you see these elevators going up, you see the Boeing, airplanes with a nice predictive maintenance. All these solutions always start with connectivity. It's always driven by data. It's always about actionable insights focused on data, but that data has to come from somewhere. And that's where integration is. So if there's one thing that you can take away, is that integration has never been as important as today, because all the integration stories that we have been doing in the past, think about enterprise integration, B2B, EAI, ESB, whatever, these things typically remain. And there's just a lot of extra solutions and a lot of scenarios that get added. Think about IoT. People that want to have that data in their cloud to do that intelligence, they need the plumbers. I'm happy to be that plumber with our company. It's important. We need to be able to get that data from all these devices deployed worldwide a lot of times. We need to get that data in a central place, and we need to do that reliable, secure, and all of that. And that's really integration that matters. So first of all, it starts with the connectivity. If you have these devices can be deployed in factories, they can be in cars. We have a customer that is in mining. You need to be able to have that data connected, these devices. So there's 3 typical patterns that we see, or challenges and the connectivity points. The first one would be the direct connectivity. So if you see consumer things like the nice hairbrush that is smart, that detects if you're getting old or whatever, these things typically are having a direct connectivity. Maybe they will use your GSM or your mobile network, but typically they have a direct connectivity. So gadgets and things like that, smart toasters, they typically have built-in connectivity. What is important with direct connectivity is that for an end user, it's easy to configure, to install. You just have that one device, and it has everything embedded. What's important is that for a lot of customers that sell these devices, especially if they have existing devices that are deployed into, for example, industrial solutions, there we see that these customers don't want to have their machinery that is mission critical, that is producing, I don't know what, bottles or food or things like that. You don't want to have those machines necessarily directly connected with the cloud, because it feels less secure. I'm not saying it is less secure. You can still do it in a secure way. But most of these customers want to separate the machine logic, the process logic, from the internet connectivity. So we've had a customer that is making machinery that gets deployed at his customers. And initially they were thinking, okay, we will have, we have these existing process control systems, and we will just add the Azure IoT SDK, add these few lines of code, and connect everything into the cloud, and we're done. And that's fine for a proof of concept, for that initial, nice demo. But then they started to realize, oh, we have to think about buffering, retry, and all these things. And we have to do that for all the different types of machinery that we have. So we see typically that direct connectivity from the machines in industrial scenarios is really not what you want to have. So this is more of the new type of devices that get deployed in consumer space. What we also see a lot of times is cloud gateways. I don't know if you're familiar with Sigfox or low-band connectivity like LoRa. That's a very interesting protocol to work with. So I'll take the example of Sigfox, but it's very similar to LoRa and other narrowband networks. The good thing is that you have these devices. So one of these customers that we work with is having containers with recyclable materials. So these materials need to be recycled, and they just attach track and trace. So a GPS device. They attach it to the fridge, for example, and they can track it. So that device is sending every, I think, 10 minutes, its longitude, latitude, where it is. That's fine for them. The good thing is that they don't need to have internet connectivity. They don't need to think about that container. Do we need a gateway to connect? No, that device has everything built in because of Sigfox. It has an automated, radio-driven communication with the Sigfox backend. And it runs on batteries. And you can have devices that run on batteries for 7 years using that protocol. So you don't need to think about connectivity. It's just there. It does roaming. It's just, including internal communication. So it has all of that. And us, from an integration point, the only thing that we have to talk with is the cloud-to-cloud point. So we get the devices are sending into the Sigfox backend or the LoRa backend, and on that backend, we can just enable forward rules to the backend that we have. So that's very nice to start from an integration point of view, because all the mess of retry, connectivity, battery, all the device things are really handled by that ecosystem of Sigfox or LoRa, and we can just start with the cloud-to-cloud connectivity, and we can work with the messaging data. So that's very nice, but it's not always possible because it has its limitations. If you want to have these devices running on batteries for 7 years, yet you don't want to send big payloads, you don't want to send every second data, because that's not possible. It has its limitations. So for smart parking sensors, for temperature sensors in the field, that's perfect, but it's not always the case for for the more complex scenarios. And that's why we see that field gateways are really more and more common, especially in the industrial scenarios. And most of the customers we work with are in that position. So with a field gateway, what you have is that you can really have devices, sometimes existing devices, that actually connect with on their local protocol with a field gateway. So a field gateway acts as a BizTalk, if you want, just cheaper, lightweighter. But it connects to the local systems, to the devices using whatever protocol is implemented, and it forwards that data into the cloud. And on the same thing, it listens to the cloud for commands and things like that, and forwards that to the right connected machines. So it's really an opportunity there to have your existing legacy devices internet-enabled. And you don't have to care about all the buffering and the retry, and what about if my internet is disconnected and things like that. That's really something there. And the gateway is just one point. So if you have 10 different device types in your factory, the gateway could be that one point that handles all the security and all of that. You don't have to reproduce that every single time again. So field gateways are really, really more and more used, especially in these industrial scenarios. Now, another finding that we found was that, of course, there's a big difference in proof of concept versus real-world deployments. Everyone knows that it always starts with a proof of concept. There's just one big risk. After a proof of concept, customers have to realize that the proof of concept typically focuses on quick value creation. You focus on the nice Power BI reports, the business rules, things like that. The basic integration skills, that's where you focus on. You typically don't focus on the things that you have to focus on when you start thinking about your real-world deployments. Yeah, what about reliability? Yeah? A lot of times you have been using simulators in your proof of concept, and then you start to realize, oh, the devices that we have to deploy now, we have to think about all the things like remote updates. One example I can give is a customer that makes a ventilation system. He deploys it, or he makes it, he produces it. It has to have some initial IoT connectivity on it, like a call home address for the activation and the provisioning, because the time I'm producing my machine, my ventilation system, I don't know if it will end up in Asia at my customer there, in Europe, or in America. I just ship it in a batch in one production order, and then it gets in the retail, and it ends up at the wholesale, and eventually it will end up at an end customer that has to install it, maybe using an installer person or doing it themselves. And they typically just have the app. So at that moment, the moment I'm shipping out as a producer of these machines, I'm shipping these devices, I lose control over those devices if I don't think about it. It's the only time, or it's the last time you can do something about it. So if later on you have things like security leaks, or if you found out that sending every second data becomes much too expensive in your cloud, but you have shipped these devices, you cannot call those customers because you don't know necessarily who they are, you don't know how to reach them, you don't know where it is. So it's important that you can still update, you can push updates, you can configure settings. Yeah? If there's a security change in certain cryptic algorithms that get, that are now secure, but maybe in 3 years no longer because of I don't know, NSA or things like that, you maybe want to have different thing, use a different crypto algorithm and push that. Because think about the toaster example and the baby phone things, where a big denial of service attack was held because they were hacking all these devices that were actually acting as a server, if you want, and they were acting or making a big distributed denial of service attacks. I'm pretty sure that these devices are still open and still unsecured, because most of these customers don't even know that their, I don't know, toaster, their smart toaster, was part of that big denial of service attack. So things like that you want to think about. And that's really where customers are underestimating the cost they typically have to do before they ship devices into the wild. So that's what we see in the real, is that if you focus in the proof of concept, typically you focus like quick connectivity, quick data storage, and then it's all about the nice integration stories, the nice visualizations, the nice business rules. But if you then show it to the real project, that's where you see that all the time gets spent and all the money initially gets spent in the connectivity, because that's there's only one chance to get that right. If you do that right from the beginning, then you know that you can update the devices, you can push firmware updates and things like that later on. Adding things like analytics and so on, that's easy, and you can easily update and grow that because you own that, typically that cloud backend. But the devices that get deployed in the wild, that's really where you have to think about initially. Now, that leads me to another thing that we find is that there's a lot of existing devices, a big install base at customers, especially in the industry. Think about traditional protocols, devices that PLCs that have OPC protocols. Think about your SNMP devices that might be here in this building. We see that a lot of these customers, including one that we are working now with which has industrial coffee machines. These coffee machines have existing protocols using like RS232, serial ports. They just want to read that data locally, and that's where a gateway comes in again and connect that into the cloud. So that's a retrofitting challenge. 85% of the devices, at least according to IDC, is not yet internet ready at this point. If you have a big install base, an existing install base, and you can internet enable these devices using a gateway, for example, you can really speed up things and you can make sure that you have less development effort than you do. Also the edge, I'll be talking a little bit about that, but doing a lot of processing on the edge before you're sending it into the cloud. So the edge is like still in your local data center, if you want, or your local deployment. If you do filtering and things like that, you can save a lot of costs before you pay everything into the cloud. So customers, they don't want to spend all their effort there. They don't want to spend time in their custom protocols and about that buffering and their retries, but they have to if they do everything themselves. They want to spend time here because that's where they want to spend, or where they want to create the value. That's in the analytics, that's in the machine learning, that's in the predictions, that's in the integrations, because an IoT solution will never be in an isolated environment. You've seen a lot of demos today. If you have actionable insights, you don't want to just show it on a portal. You don't want to send an email. You want to have it integrated with CRM, ServiceNow, just name it. And that's, again, where the ecosystem of Microsoft Azure, in this case, really will help you. So a gateway typically has a lot of different responsibilities. It has to think about activation and security. That's where it all starts. If I'm starting up my gateway, I'm enabling it for example, ventilation system. I need to do an initial handshake. I need to do a call home. That gateway has to be provisioned on my backend, and then I have to download all the, firmware. I have to download the configuration and things like that. That's really something that is typically handled by the gateway. Also, if you have a local protocol, a lot of times you see that that protocol itself is really unsecured. A lot of existing devices in the industry, once you get into the local network, you get access to almost everything, because they consider it as it's just local, we secure it on a network layer. That's not really true. If you want to open those things up to the internet, then you will run into an issue. So again, if you have a gateway that handles that security handshake, you're in a much safer position. And that's where service-assisted communication comes in. But I think we'll have a session on that later. No, that's not that. Okay. Another important thing is, of course, that you want to have health monitoring. If you have these devices deployed worldwide, you want to know which devices are no longer connected. Because, I don't know, a local factory installation can have an internet cut or things like that. You want to know that. You want to act on that. And again, you want to get events to integrate that with your own system. You want to configure everything. If you have a new device that a gateway needs to monitor locally, you want to configure that in a central place, not by doing a remote desktop to that gateway. No, you want to do that in the cloud backend, and that configuration should be picked up by that gateway. Remote updates is something that I talked about, command processing, and then the edge filtering I'll get back later on. One of the most important things that we find with gateways is that you have the need for extensibility. Because of all these different protocols, there's really not a lot of standardization in that device and embedded atmosphere. You have, of course, SNMP and things like that. We see that OPC UA is getting more and more traction. But if you look back at the 10 years and more install bases that we see, there's a lot of custom homegrown protocols, and you really want to accept that as well. So you want to have extensibility and inject your own protocol adapters if you want. And again, that's again a point. These are the things that we have been doing ever since, right? We've been connecting with SAP using standard adapters, but then suddenly we come to a customer that has an ERP system that we've never heard of, and we have to do some plumbing and some connectivity to get the data out of that. This is pretty similar in IoT. And there I have my first typo. But never mind. A common gateway activity that we see is the edge filtering or batching. So as I said, you have these devices, and a lot of these devices are just sending data, spitting data like every 5 seconds. It's 25 degrees, it's 25 degrees, and you know that the temperature typically doesn't change that much. So if you want to do a one-on-one forward of those messages into your cloud backend, and you have to pay typically message-based, that will typically cost you. Also, if you have an expensive connectivity between your local network and the cloud, 3G or things like that, it will start to cost. So a gateway typically will do filtering, will do batching, and will maybe only send the temperature if it changes more than, I don't know, 1%, things like that. It will also compress. We've seen JSON files at customers that were rather big, and we were using Avro, which is a compression technique also supported by Stream Analytics. We were using that to compress and send that into the cloud. And then, of course, aggregation, like you want to take the average temperature over the 5 minutes instead of having everyone send. So this is very common there. Now, one of the things that we have been doing together with Microsoft IoT is working on the Nebulous IoT Gateway. So this is a product. It's actually a software gateway. A software gateway that you can run on Linux, on Windows, on a small device, or on a big server. So you really see it independent from the hardware. And of course, we have different partnerships with hardware vendors. And what we really want to do is make sure that you have all the cloud capabilities, monitoring, remote updates, remote management, all of that handled by the green cloud, which is the Nebulous backend, but that all the data, all the telemetry, because we have sometimes patient information, and all that telemetry is being sent into your cloud being your subscription, your data storage, or even your own data center, wherever it is. So that's what we have been doing, and we have applied all the principles that I just talked about in this product. And why? Because we see that bringing the cloud capabilities to the edge, so the edge is in your own deployments, is really key, especially in enterprise. I'm not talking about the smart toasters. I'm talking about enterprise IoT, because that's what I believe that most of us, especially partners and customers, will be involved with. So the edge is something that becomes more and more important, and we see that IoT in the cloud is where you do your machine learning training, where you have the integration, consolidation, data analytics. That's what you want to do in the cloud, because there you look on the data from your different tenants and your different devices. You have unlimited compute and so on over there. Now, what you typically want to do on the edge, as I said, the filtering and so on, low latency actions, We had a customer that says, no, I don't want to depend on the cloud, on my internet connectivity, to take a local decision. If this machine says that his temperature is going too high, I want to take immediate action and say that the other machine in my production line has to stop producing, things like that. That's an action you don't want to depend on the cloud. If you want to have your self-autonomous car, I don't think you want to depend, if you're riding in a tunnel, on an internet connectivity to see if you're hitting a wall or not, right? These things are decisions that have to happen extremely low latency on your local protocol. And of course, the privacy and data is something that gets more and more important, especially in countries like Germany and so on. Now, what we also see is that these edge scenarios, and there's a lot of them on this slide, is that they have a variety of complexity and of compute needs, right? And what we see is that the more you are on the, I should not do that, the more you are on the left bottom corner, the lighter your hardware can typically be. The more you are on over there, for example, that autonomous car, the heavier your compute power needs to be to take those decisions, because you have a lot of custom code, a lot of custom decisions, and you still want to have extreme reliability for scenarios like that. And what has been announced recently at the Build, I think that's been almost 2 months ago, is Azure IoT Edge. It's been announced, it's not available, it's not even in private preview. It will get there soon. But Azure IoT Edge is a product that Microsoft announced that will typically run in your local, for example, factory. It is something that they consider, of course, as it should take all these things like security, like managed from the cloud, cross-platform. So you will, as you know, that Microsoft is really embracing open source and so on. It will run on Linux, it will run on Windows, and it should be portable. And of course, extensibility is key. This is an architectural slide that they have. And without diving too deep into the things, for example, the twins, because that's something that Mikael will do, what you can see is that you have your IoT Edge is actually the agent. It has container management. It has your functions runtime. So if you've seen a session of Jeff yesterday with functions, you saw that he could take that function runtime locally. Remember the funky commands, func new and things like that? That function runtime will also be running in Azure IoT Edge. The same thing with Stream Analytics, and that's something that is in a preview at this point. Stream Analytics is a service that we all know from the cloud. You will be able to run your Stream Analytics queries that you maybe have deployed in the cloud. You will be able to run that locally on this thing that is called Azure IoT Edge. Machine learning. Machine learning is complex, and you need a lot of compute power to train your models, right? You need to work on all that data, crunch everything, and have all these algorithms executed. But once you have a model defined, executing a model is peanuts. It's just a few lines of compiled code. So you will be able to have your model trained in the cloud, but your model executed on the edge, in your local, close to your devices. And that's what Azure IoT Edge is all about. The same things with cognitive services. So some of the services, and it's not public yet on which services of all these cognitive services, but some of those will be running on the edge as well. So think about your car that maybe needs to detect if something is human or a wall. I don't know, to decide what I should hit, I don't know. But these things, you want to have execution locally. So cognitive services is also something that they will do. And the way they will do it is by using containers. So containers is a concept that is becoming more and more popular. And it's like a mini virtual machine. So actually, they will use Docker. I think most of you are familiar with Docker. They will use Docker images that you can have in your own backend. You will have some public images, for example, the machine learning and so on. You can have your own images, and that's what we will do with the Nebulous Gateway, the green one there. You can have these in your repository. Then you can have your edge deployed. So you will have a lot of edge deployments, of course. And you can push these containers to your edge deployments. So I can say, for my edge installation in in London in this building. I want to deploy my machine learning and and then I want to set what is called a module twin, that black box. That's the configuration of that container. So you have one shared container, but then you will configure it. It's like a pipeline, one pipeline with a custom configuration, and you can configure it. And the good thing is that you have a full routing. You can route between one container to the other. So that's the module chaining that you can have. So you can, for example, use a gateway to connect data. You can then pass it on to Stream Analytics that maybe aggregates the data over 5 minutes, and you can forward it to IoT Hub. Things like that will be possible. So I believe that's a pretty promising solution. One thing that is not totally clear yet, this can cost as well. It's not because you will run it locally that you can suppose that it's free. There's nothing been announced, but I just feel that they will have a pricing model for that as well. And it could be consumption-based, even if it's in your local hardware. And that's a big change. Talking about hardware, they target a big variety, not the small microcontroller type of devices, but anything that is 128 megabytes. So think about Raspberry Pi and even below, all the way up to big servers if you want. So that could be your edge deployments. So, and why I believe that they won't do this for free, I don't think that they will allow you to spin up a server to do big Stream Analytics processing and then just forward the tiny results into your cloud. I think you will have to pay for that. But again, nothing has been announced on that one. Now, one thing that we also see is that dynamic business rules is something that we really need in projects. So most of you probably know Stream Analytics, and Stream Analytics is something where you define rules, but it's more static. It's like I create a rule, I deploy it, and it really takes part of a deployment lifecycle. Like Johan just showed, you should make Stream Analytics also part of your continuous deployments. What we see is that customers typically need more agile business rules. You've seen the Service Bus rules, Service Bus 360 this morning. You want to do that as an end user, you want to do that. You want to configure these rules yourselves. And that's the same thing with IoT. So we see that we separate typically the rules from the action. So you have rules, and then if a rule validates, I want to do an action. And what we have been using there is Service Fabric mostly, and of course, if they are fixed rules, Stream Analytics. Now, one thing that we have been building is the Nebulous IoT Rules Engine, and it's like an in-memory processing engine, very lightweight, but that allows you to have like Excel-like expressions. So I can, for example, say if the voltage of this battery is less than that in my building of Codit, then send an email. Or, and that's where we have geolocation support, if the truck that is driving, his location is less than 10 kilometers from its actual destination, then trigger an integration message, which is actually something that is put on the service bus. And of course, you can have your logic apps go wild against that. So that's something that we have been making. But honestly, I hope that Microsoft will come up with a service that allows us to do things like that. Because it's not something that, it's something that we just do to enable the projects, but I really hope that Microsoft gives this as a platform, as a service approach, where we can give to the end customers some way of setting business rules. Because that last business rule, that's a rule that is set by an operator that is monitoring the trucks, and he needs to know if the truck is arriving at its destination. He wants to see that on his dashboard, and he wants to take action. So that's something that we see that is needed in IoT, and that there's not necessarily a 100% fit solution in Azure yet. Now, to wrap up, I believe that as I assume everyone in this room has integration passion and has integration in its blood or in its DNA, I believe that we are in the right position to make nice IoT solutions. So this is the schema that we have again. If you look at that schema, there's a lot of points where integration or integration technologies come into place. So we have the legacy protocols on the client side. We have filtering, like I said, on the edge, including things like stream processing. APIs and messaging are extremely common technologies. Data integration, of course, right? Event processing. Once you go to things like Service Fabric and so on, it's all event-driven most of the times. And then, of course, the nice things are when you have all that nice data intelligence, you want to start doing integration, you want to do the report, automation, and things like that. And that's where API management and backend integration come into place. We also see that there's typically two developers personas involved. You have the persons that have been focusing on the things. So these are typically focusing on extremely strict real-time procedural programming, fault tolerance. All these things are extremely important for them. They typically use C, C++, and they focus on the process, on the machine, on the device. And then we have the internet or the integration developers, and they think more on the distributed level, on decoupling. Multi-tenancy is something that is really important in IoT solutions. If I'm a customer, if I'm putting machines of myself at my customers, I want to make sure that the data I show to my end customer is really in his own tenant and never gets, with other, tenants involved. Scalability is important. You have extreme high performance on the thing side. On the cloud side, you have all that high throughput and, of course, massive scale. That's really something that you typically want to focus on as well. And the tools you see there more is, of course, C#.NET, Node.js, and, of course, a lot of open source protocols. Most important thing is, of course, that there's integration and collaboration. I mean, I've been in the mainframe integration. I know that languages were totally different there. If you ever talked with a DB2 administrator as a Microsoft person, you know that language is difficult. You see these things coming back. People on the device side, they talk about modules. They care about every single megabyte that they have to spend on their tiny devices, while we think about distributed applications and so on. So I think it's a really important thing. What I believe that is important and that we have not necessarily been seeing in the past years is things like data analytics, data science, because that's where the value gets created. Multi-tenancy, resource deployment and automation. The session of Johan was a good example of that. We really need to focus on that. If you deploy a new tenant, that should typically be automated. And of course, all these special protocols. We all know SAP and Oracle by now. I think we will have to start looking more at OPC UA, at MQTT, and these more wire-level protocols as well. To wrap up, I'm happy to announce that we also have a free IoT workshop. You can subscribe on the following URL or come and see us at the booth. And there's some interesting material that we have. 2 white papers that we wrote, one on the field gateway principles. You can download them on those URLs. And we also have the integration of things white paper, where we talk about the differences and comparisons between IoT and integration. We have a few hard copies at our booth, and of course you can download it from the page. And we have the webinar about IoT gateways. I don't think I'll have time for questions, because I'm exactly on time. But of course I'll stay here for the rest of the conference, so feel free to grab me afterwards. And I think now we will have more a technical session that dives into these principles by Mikhail. Thanks for the attention. See you later.